Today in this video, I would like to share what is the difference between the silicon diode and Zener diode. So I have two types of the diode here, and one is IN4007, which is 1 ampere maximum and 1000 voltage maximum voltage. So below 1 ampere you can use, and the maximum voltage input will be 1000 voltage. So this is a very common diode, and this is a very wide range. This is a very wide range use, and this is a very common use because the ampere current is 1 ampere and the voltage is up to 1000 voltage. So if you already understand how to use and how work this diode, and this is very simple, that you're gonna understand all of the diode working. So every diode, they will have the specific number which will represent for the ampere and the voltage. So once you want to choose your diode, you have to check your part number, which will be represent the voltage and ampere. So to testing modes, that is a very simple, and all the diode is basically the same for testing mode. So one side is the full black, and the other side is there is for gold color. Either is gold color or you will see a little bit white color. So the full black side is anode and the other side is cathode. So basically the diode is the current we allow to flow one way. So from anode to cathode, the current will flow from this way, and once the current, in case something is short, then they will not, the diode will be blocked. So in that case, your circuit board will be safe. So this is the purpose why they need to use the diode. So how we can test? So from anode side, you need to place the red lead. We have to select, of course, multimeter to diode testing mode. So I'm going to select to diode testing mode here, and then so here, so anode to cathode. So every single diode, the normal silicon diode, the voltage will drop will be 0.5 or 0.6. So which means if your supply is 12 volt, then you will be drop 0.5. So the output will not be 12 volt anymore. That will be 11.4. So because 0.58 is already dropped, this is we call diode voltage drop. So to be understand more easier, here is for this normal diode working. So let's say you supply 9 volt battery. So 9 volt battery, they will go through with the diode, and the output you will get 9 volt. So as I mentioned, this is will not be 9 volt anymore. Let's say you are 9 volt, then you will get probably 8.45 voltage, because you have 0. Normally it's 0.6 or 0.5, that's around like that. So let's say if I'm gonna test with the breadboard here. So this, the black side is for anode, this side is cathode. Just place like this. Right, anyway. So this is positive. Right, then this is negative. So you can use either is 12 volt, 9 volt or 24 volt. So any voltage below 1000 voltage you can use, and the current draw will be 1 ampere, which means your output, the load cannot be more than 1 ampere. So let's say you cannot drive the big size of the motor, you can just drive a small size of motor if you use this small diode. So let me check the voltage here. So of course for the DC input, I get my input voltage is 9 volt here. So 9.4. So my primary input voltage is 9.4, 9 volt battery, because this battery is new. So I get 9.4. So after diode go through, you can direct test from here. So 9.12. So this always will be a little bit drop. So if your diode is not drop so much, that means your diode is considered very good. So I get 9.12. Because in between here, once the voltage is already passed through this diode, there is a 0.4, 0.5, 0.6, the plus minus 5%, there will be voltage drop. So this is how the diode working, and this is how the way they use the diode. And not only for this position, they use many range and many types, many designs, and especially the diode is they use for AC to DC converter. So especially once your transformer output is AC, then you need to use either its diode or the bridge rectifier then to convert to the DC. So once you already convert to the DC, then the voltage will not be reversed anymore. So this is how they use the diode. So this is the another types of the diode. We call this is the Zener diode. So every Zener diode have the breakdown voltage. So starting from 2.5 voltage, 3, 4.2, and 6, 6.2, a lot of the range, the Zener breakdown voltage. And how they use this is the forward. I get 8.9 voltage because there is a voltage drop only for 0.7 voltage. So this is the normal using. If you reverse, then you will get the output according to the Zener diode voltage. So my Zener diode is 3.3 voltage. I should get 3.3 voltage. Yeah. But if you use normal silicon diode, which is 1 ampere, then this is the normal position. You will get 7.9, okay, 8 something. And if you reverse here, and you will not get any voltage because this is totally blocked. So this is how the difference between the normal diode and Zener diode working. At first, the normal silicon diode I'm going to use here. So positive to the negative, anode to cathode. And if you apply here 6 volt Zener diode, so once I apply the 6 volt Zener diode, and the output will be 6 volt. I'm using this is 6.2 voltage. So here let me check. So if you apply here, this is how many voltage Zener diode. And my Zener diode is how many voltage? Let me check. Yeah, this is a 4. So basically my Zener diode is 3.9 voltage, but I get here 4, which is plus and minus a little bit, so this is good. So if you apply 12 volt Zener diode, you will get 12 volt. If you apply 6 volt, then you have 6 volt, but the voltage input must be higher than the Zener diode. Alright, so this is how the way the Zener diode and the normal diode different, and this is how the way they use. And I hope you understand this video, and thank you for watching.